In this lecture, we are going to talk about the last storage class that you are supposed to learn, and that is called as the register storage class. So we can create a register variable by using this keyword called as register. Okay, now register storage class is really interesting. It is not going to store the variable in the memory, but it will try to store the variable in the register memory that is available in the CPU. So it is going to directly store the variable inside the CPU. Okay. Now while you are programming, sometimes we need certain variables to be accessed very frequently. So if you have certain variables to be accessed very frequently, it is better if you store that variable in the register, because CPU registers are very fast. Okay, so we have this memory hierarchy I've demonstrated here. So we have got the hard disk at the lowest level and the CPU register at the highest level, right? So hard disk is very slow memory. Okay, RAM is faster than hard disk, and we have something called as cache memory, which is faster than the RAM memory. Okay, or the primary memory. RAM is the primary memory, cache is faster than the RAM, and CPU register are the fastest of the memories that we are having in any computer system. Okay, so they have very fast access time, and hard disk is having a very slow access time. But if you look at this memory in terms of the cost per unit, okay, CPU registers are costliest of memory. You have to pay more price for getting 1 unit of a CPU register than the cost for the cache memory. Okay, and the cheapest of the memories is the hard disk. So hard disk is the cheapest of the memory, but it is very slow. Okay, similarly CPU register is the costliest of the memory, but it is extremely fast. So whenever you have got a requirement wherein you are having a variable that needs to be accessed very frequently in a program, in that case you can store that variable as a register variable. Okay, so creating a register variable is just a request. Okay, whenever you try to create a variable as a register, if the free register is available, the operating system may allow you to use that CPU register in your program. But if in case free register is not available, your variable will be stored in the primary memory or in the RAM. Okay, so creating a register variable is a request but not an order. So now let's try to demonstrate the working of the register variable. So in this program I've created a variable A. It's a normal variable, a variable that is actually defined into this block, so it is an automatic variable. If I want to create any variable as a register variable, I'll be using this keyword called as register. So I'll write register. Okay, register int. So let me create B as a register variable. So B here is an integer variable and its storage class is register. Now the operating system will try to store this variable B in the CPU register. If the free register is available, it will be stored in the CPU register. Therefore the access time would be fast for accessing this variable B. But if the free space is not available in the register, if the free register is not available, then it will be stored in the primary memory or in the RAM. Okay, so now let's try to see what it does. Okay, let me try to assign some value to A. So A becomes 10. Okay, I'm not assigning any value to B. Let's see what happens if I don't assign any value to B. Let's try to compile this code. Okay, compilation is successful. Let's try to run this. Now you see B is 1. That means B is taking a garbage value. So by default, register variable will take a garbage value. Okay, if you have not assigned any value, it will take the garbage value. So let me now assign the value 20. Okay, if I now assign the value 20 and if I run it now, you get B is equals to 20. Okay, this is working fine. So in this case, the variable B is stored in the CPU because it's a register type. Okay, so the access time of B is very fast. Now because this is stored in the CPU, you can't get the address of this variable. I'll just write it here. B is stored in the CPU. Okay, so you cannot have the access of its address. Okay, like normally A is a normal variable, right? You can have its address, right? So let me try to print the address of A first. So how do I print the address of A? It's very simple. I just write printf. Okay, we have already known this operator, address of A equals to %d. Let me print the address in terms of decimal. So and write %a because ampersand will give us the address. Okay, we all have to note that ampersand is the address of operator. We have already discussed this while doing scanf, right? Address of operator. Okay, so ampersand will give us the address of that variable. So let's try to see what is the address of this variable A. A is not a register variable, so let's try to compile this code. Let's run this. Now you see this is the address of A. This is a big integer number. This is the address of A in the memory. In the RAM, this is where A is stored. Okay, in this location the variable A is stored. Now similarly, let me try to print the address of B. Okay, let me try to copy this statement and paste it here. Okay, so I'll just write address of B is what? I'll just write %b. B is a register variable. Okay, B. Okay, so let's try to save this, compile this code and then now you see an error here. The error is address of register variable B requested, but you can't actually find the address of the register variable B because the register variable is not stored in the primary memory or in the RAM. It is stored in the CPU, right? So you can't find the address of a register in the CPU. That is not allowed. Ampersand will only find the address of a variable in the memory, in the primary memory or in the RAM, but not in the CPU. If you are somehow given the address of the CPU, you think of it, right? You can spoil the entire CPU. So therefore, it is restricted. You can't get the address of the CPU register. Okay. So by this, we can confirm that B is not stored in the memory, rather it is stored in the register. Therefore, the access time of B has improved. Okay. So sometimes in a program, whenever you have a variable, let's say you have a variable that you are using in a loop. Okay. The variable I in a loop. Now let's say you are using that variable multiple times, you are having the more access to that variable. In that case, if you make that variable store in the register, right, the access time would be fast. Therefore, it will improve the runtime of your program. Your program will run faster. So that is the use of the register variable. Okay. So in this lecture, we have learned how register variable works, and we have also learned about the memory hierarchy. We have learned about hard disk, RAM, cache memory, and the CPU. CPU has its own memory that is called as register, which is very fast, but it is very costly. Hard disk is very slow, but it is quite cheap. Okay. Now, if you have to talk about the scope, what is the scope of the register variable? The scope is the block where it is defined. It has a block scope. So this variable B is having the block scope. That means it is only available or valid in this block where it is being defined. And what is the lifetime? How long it is active? It is active till the end of the block. Okay. Once the block ends, the lifetime of the register variable also gets over, right? So in that case, you will not be able to access the variable after the block. Okay. So this is the lifetime, scope, and the default value of the register variable. So I hope you have understood how register variable really works. So that's all in this lecture, and this is the last lecture in this particular section. In this section, we have learned about different storage classes, and we have also learned about how to create our own header file and how to do multi-file programming and multi-function programming. So that's all in this section. Now we're going to start with a very interesting topic, the concept of arrays. Okay. So until then, stay tuned.